All right, so what we're looking at here is integrating trig functions, and so far the only integration that we've done with trig functions have been doing the opposite of the derivative, okay? So we know that the derivative of tangent is secant squared, so if we happen to be taking the integral of secant squared, we know it equals tangent, all right? So we had some of those that were kind of nicely set up for us. The only two that we got that were actual trig functions were the sine and cosine. Okay, so what we're going to do today is introduce the other four, the integral of tangent, cosecant, secant, and cotangent. All right, so let's start out here working with some of these, okay, and kind of getting a little bit creative on these. And I'm actually going to start with the second one and then have you get with some friends and try the first one here. Okay? And I don't want you just Googling it. That totally defeats the purpose of actually trying to get creative and figure these things out yourselves. Okay? But let's start with the second one. The second one, you're going to ask, well, how in the world did someone come up with this? And all I can tell you is that they did exactly what we were talking about earlier, and that is just they tried stuff, and they tried to figure it out, okay? So like here, we do the integral of secant, and you might think, okay, well, maybe I could make that 1 over cosine and use u substitution. But if u is cosine, to get u prime over u, I need a sine on the top, and there's no way to get that in there. You might even think of using your Pythagorean triples or your Pythagorean identities, and hey, 1 plus tangent squared is secant squared. So secant itself would be the square root of 1 plus tangent squared. And then you might do some other stuff with that and work it around, and eventually if you kept using trig identities, you'd be simplifying stuff, and then it would come out to square root of secant squared, and you're right back where we started. And you find out that, hey, that's really cool that all that connected, but that didn't get me anywhere. Okay? So eventually somebody figured out we can multiply by a form of 1. Okay? And the form of 1 that we're going to use is actually secant plus tangent over secant plus tangent. All right? Now you're saying, well, how in the world could I have figured that out? Well, it took somebody a long time, most likely, to figure this out. But again, they just tried stuff. So here's what we're doing. The integral of secant x, we're going to multiply by secant plus tangent over secant plus tangent. And you might be thinking, okay, well, that just got a whole lot more complicated. Okay. But actually, what we're going to end up doing is if we distribute here, we end up with a secant squared plus a secant times tangent. Now, those might look a little bit familiar. Those are derivatives of trig functions, right? In fact, secant squared is the derivative of tangent, and secant times tangent is the derivative of secant. So let's think about this, okay? If we make the u equal our denominator now, secant x plus tangent x, then the du is going to be the derivative of secant x tan x, plus the derivative of tangent, secant squared x dx. And now you can see here, there's my secant squared plus secant x tan x dx. So now I have u prime over u. Okay? Now, we could have probably taken a month on that, and maybe someone would have come up with that. All right? But thankfully, somebody tried this at one point in history. Okay?
Do we have to know like how to solve it, or we just gotta memorize?
You don't have to know the derivation, but seeing the derivation kind of gives you an insight as to how the other ones were most likely derived as well. So now we see this. This is 1 over u du. What's the integral of 1 over u du?
Ln u.
Ln absolute value of u. Okay? So ln absolute value of u is the ln of the absolute value of secant x plus tan x plus c. And that's how we get the integral of secant x. It's the ln of absolute value secant x plus tangent x plus c. Okay?
Yep.
So that's pretty cool.
It is.
Now, what I want you guys to do here, we've seen one of these. What I want you to do is go back up here to tangent x, and I want everybody working with at least one other person. Okay? So take a few minutes and see if you can't figure this one out. Alright, good. So eventually we figured out here to start out with tangent is sine over cosine. Okay? Alright, so let's get back to this here. So we're really taking the integral of sine over cosine. Okay, so now you see a rational function. So the first thing that comes to mind is trying to get what? Yeah, the u prime over u or du over u, okay? So we're trying to get that. So we're going to let the u equal the cosine, the denominator, and then du is negative sine x dx. Alright, so all we're missing here is the negative. So I put a negative on the inside and the outside to cancel each other out. And now I've got negative integral of 1 over u du. And you know that that's then negative ln absolute value of u, which is negative ln absolute value of cosine x plus c. And that's how we get there. Yes?
So you put a negative on the outside and the inside, but like, wouldn't that cancel out the net? Because it's negative sine of x, so that's technically like multiplied by -1. If you pulled that out, you would then get a positive.
Yeah, and that's the whole reason why we did that. It's the same thing if we needed a 2 here, we'd put a half out here, because they would cancel out. Because we can't change the problem by just throwing a negative in when we feel like it. We gotta multiply by 1. So one form of 1 is -1 times -1. Okay. All right, good. So
I feel smart.
we get a little bit creative and figure that one out. That's good. So here we have all 6 rules. We derived 2 of these other 4 that we hadn't seen before. But notice how cotangent and cosecant are very similar. Okay? Cotangent and cosecant are very similar. Cotangent similar to tangent, but it's positive ln of sine of absolute value of sine of x. And cosecant similar to secant, but it's negative ln of absolute value of cosecant plus cotangent plus c. Okay? And by the way, keep the positives and negatives straight. If the answer has trig functions that start with c's in it, the answer is negative. Okay? Just like when you took the derivative of something starting with c, the answer was negative. Here, when you take the integral, if the answer has cosine, cosecant, or cotangent in it, it's going to be negative. Okay? So, let's try actually using this here. We need to evaluate the integral from 0 to pi over 4 of the square root of 1 plus tangent squared. Well, when you see something weird like that, especially with trig functions, you got to start thinking about, is there anything I could replace that with?
There's identity.
Okay, what's 1 plus tangent squared square rooted? Okay, 1 plus tangent squared is secant squared. So I'm doing the integral from 0 to pi over 4 of the square root of secant squared, right? And of course the square root of secant squared is secant, okay? So those cancel each other out. And what do you know? We just figured out what that equals.
ln of the absolute value of secant x plus tan.
Yes, ln absolute value secant x plus tan x.
Evaluated from pi over 4 to 0.
There we go. Evaluated here from 0 to pi over 4. Okay? So we got to be careful a little bit here as we're plugging stuff in. So we have ln absolute value of, what's the secant of pi over 4?
Still 1.
What's cosine of pi over 4?
Doesn't exist.
Oh, it does. Huh? Radical 2 over 2. So secant is 2 over radical 2. Okay? Because cosine's root 2 over 2, so secant's 2 over root 2. What's tangent of pi over 4? 1. Okay? And then minus ln absolute value of, what is the secant of 0? What's cosine of 0? 1. So what's secant of 0? 1.
Oh, we're smart.
And what's the tangent of 0?
0.
0. Oh, okay. So now I'm taking ln of 1. What does that equal?
0.
That whole thing is 0. So now I just have ln, the absolute value we don't care about because it's positive anyways. Ln of, this is 2 over root 2. If I rationalize that, that actually ends up just equaling root 2.
Yeah.
Okay? So root 2 over root 2. The 2 will cancel with the 2 on the bottom. So it's ln of root 2 plus 1. And you can leave that like that. Okay? Yeah, that's the area. If you remember, secant has asymptotes whenever cosine was 0, which was at pi over 2, and negative pi over 2, so it looked like this, and then jumped down and so on, had asymptotes. So we're taking the area from 0 to pi over 4. So this area right here. Okay? That's what we were finding. Okay?
Can we use our calculators for these problems?
This one? Probably not. Okay? There's no reason you need a calculator for this one. Okay. It's all unit circle stuff and trig identities and so. Alright, so now average value of tangent on the interval from 0 to pi over 4. Okay, average value of tangent. Tangent, you guys know, looks like this. Okay, it's got asymptotes at negative pi over 2 to pi and pi over 2. Okay, we want from 0 to pi over 4. This little area here. Okay. But we want the average value, okay? So how am I going to use the average value? I'm actually not getting area. I'm getting whatever the average value of that would be.
So you have to get capital F of x.
Okay. How do we get average value?
Take the endpoints.
The integral? Capital F of b minus capital F of a over b minus a.
Okay. Which is, what do we call that, guys?
Normal.
What theorem is that?
We're the two theorems, right?
Mean value theorem.
Mean value theorem. Okay, listen, guys. When you hear average value of a function, automatically you ought to be thinking mean value theorem. If I want the average value of f, I'm going to do 1 over b minus a times the integral from a to b of f of x dx. Okay? So, if I want the average value of tangent from 0 to pi over 4, I'm doing 1 over pi over 4 minus 0 times the integral from 0 to pi over 4 of tangent x. Okay? Now, what is the antiderivative of tangent?
Negative ln cosine of x plus c.
Okay, so the integral of tangent, negative ln absolute value of cosine. So we're taking this is going to be 4 over pi times negative ln absolute value of cosine evaluated from 0 to pi over 4. Okay? Yes?
And the mean value, you're basically just dividing by the distance, right?
You're dividing the area by the distance between A and B. Yes.
Okay.
Okay? Yes.
Sorry, can you just move? I can't see the box.
Okay? So, real quickly here, we have 4 over pi times negative ln of cosine of pi over 4. Ln of, what's cosine of pi over 4?
1. Or square root of 2.
Square root of 2 over 2. So negative ln of square root of 2 over 2 minus negative ln of 0, cosine of 0. What's cosine of 0? 1. Okay? So ln of 1 again equals 0.
Oh, but this Hickson, if you don't have a calculator, how do you find the number, well, what ln of root 2 over 2 equals to?
You would just leave it.
You just leave it.
Just leave it that way?
Because that's
Yeah.
the exact value.
There's our exact value. That's going to be our answer. Okay? Again, we don't need a calculator for this one. This is just our answer using unit circle and trig identities and all that stuff. Okay?
Alright.
So there we go.